Hi everyone, this is Liam Eagle from the Web Host Industry Review, and I'd like to welcome you all to the today's WHIR webinar, Building a Computing Cloud. Today we have Shannon Williams of VMOps and Jason Baker of ReliaCloud and VISI. We'll be delivering you a webinar that will show you a few things about VMOps technology and how it's going to help hosting providers to build a cloud computing infrastructure that will allow them to provide cloud-based hosting solutions. I'm going to start out by, let's just go to the agenda here. So I'm going to start out, I'll just introduce the two presenters. Shannon Williams is VP of BizDev at VMOps. He leads the company's focus on the hosting and service provider market. He has a long history of working with successful Silicon Valley startups, including management roles at firms that have been acquired by Citrix, McAfee, NCR, and EMC. Jason Baker is CTO of ReliaCloud and VISI, which is a regional hosting provider based in the Minneapolis-St. Paul area, and is one of the sort of early adopters of the VMOps technology, so he can give you some good insight into how that's going to work. The way that the thing's going to go is I'm going to turn it over to Shannon very shortly, and he's going to take you through a bit of a presentation detailing some of the technology and how VMOps works, and then he's going to go through a bit of a live demonstration of the interface, and then he's going to hand it over to Jason, who will give you a bit of a sort of case study look at how VISI is deploying VMOps with ReliaCloud, and then they're going to pass it back to me, and I'll take attendee questions, and I will pass them to the presenters, and they can sort of answer your questions as we go. Or sorry, they can answer your questions during the Q&A period at the end. Now, if you submit questions to me using the webinar control panel here, and if they're really topical, I might find spots to pipe in and submit questions that are really relevant to the subject at hand. Otherwise, we'll keep them all to the end, and there'll be a good chunk of time at the end where questions will get answered. Now, we've got quite a few people here today, so we might not get to every single question. If your question doesn't get answered in the course of the webinar, we're going to follow up afterwards with email with everyone. We're going to record everyone's questions, so hopefully we'll get them all answered. Excuse me. So right now, I'm just going to turn it right over to Shannon.
Liam, thanks for setting this all up, and thanks for hosting the webinar today. I hope everyone can hear me fine. It looks like we have a fantastic crowd, so hopefully we'll be able to go through a lot of information and give you guys a good presentation and an overview about what it takes to actually build a computing cloud. So I'm going to start by trying to go through a little bit of the high-level stuff relatively quickly, so we can spend most of the time talking a little bit more detailed about what it actually takes and what the technical infrastructure required is to move from a traditional managed service provider or hosting provider to a cloud computing provider. So we'll talk a little bit at the high level, but really this presentation is going to be a bit hands-on, and we're going to talk very detailed about issues like what type of infrastructure should I use, what are the different type of business models that people are exploiting in the cloud, what type of hypervisor or network or storage technology might fit with cloud computing. So as we go, please don't hesitate to ask questions via the chat console, and we'll try and answer them as we're moving along, or at the end if we can't. So one of the things that happens a lot with cloud computing things is people spend a lot of time talking about definitions, and I don't want to do that. I like this definition that the 451 group uses for what is computing, cloud computing, because it focuses on a couple of the key things from my perspective. I mean, cloud computing is an evolution of things we've been doing for a long time. It's about delivering IT as a service to end users very well, and making that, leveraging a lot of virtualized resources in that process, and making it something that end users have a lot of control over. And it's not exactly, it's not really a new phenomenon as much as you hear about it being sort of a new phenomenon. It's really something that that we've seen for a long time, and that in different shades. And so, in the last year or so, there's been a lot of kind of, language used to kind of describe what different types of computing clouds look like. And I think something that's caught on is this idea of software as a service, infrastructure as a service, and platform as a service being the three primary flavors of clouds out there, with software as a service obviously being the oldest and the most successful to date, with really very successful examples like GoToMeeting or WebEx and Salesforce and others, Gmail, that have really become critical to everyday life for businesses and individuals. But when things really started to get interesting, I think, from a cloud computing perspective for service providers was as infrastructure as a service began to take off in the last, say, 4 years. And that's when companies like Amazon set out to build virtualized utility computing type environments that anyone could get on and start provisioning virtual machines and instances to. And we're seeing now a lot of talk about platforms as a service, things like Microsoft Azure or the Google App Engine or Force.com. And the real difference between infrastructure as a service and platform as a service is that with infrastructure as a service, what customers are consuming is really still raw infrastructure. I want 5 virtual machines, such and such amount of network, storage, load balancers, backup. I really want to manage my infrastructure, but I want it to be available as a service over the web. With platform as a service, it's really about abstracting that infrastructure layer and allowing users to write applications directly on processing engines. So for today's conversation, we're going to primarily focus on infrastructure as a service because it's the obvious extension of what service providers have been doing for a long time. It's about delivering IT to your customers. And when we talk about infrastructure as a service, we're really talking about an experience for end users where they can very quickly get online, think about the type of virtual machine infrastructure they need, whether it's some combination of CPU, memory, and storage, pick the right instances, pick the right type of software infrastructure they want to run on those systems, whether it's Linux or Windows or some pre-configured application that fits with their business requirements. Quickly set up an account, provide billing information or whatever is needed to charge them, and within a matter of 5 minutes have access to a virtual private data center where they can control their own network, control their own virtual machines, manage their storage, backup, and begin to deploy the applications they're looking to run for their business. And even getting to the point of having console-level access over the web. These are all the things that people are excited about with infrastructure as a service. And I think if you drill down into that and you think, okay, well, what is really driving this? There's 3 end user requirements that are pushing people to the cloud and that are getting people excited about the driving the adoption that you're seeing in some of these public clouds. And they're really lumped around availability and giving users the ability to leverage infrastructure that especially as a small or medium enterprise, they probably haven't had the ability to do. Multiple data centers and dedicated or guaranteed resources and automated high availability or load balancing or backup and recovery or DR. I mean, more advanced services, more advanced availability that might have been out of their price range before things like cloud brought it into the equation. Beyond that, just better availability, I think there's a big driver that users actually want more control. And more control being they want to be able to do things on their own. They want to be able to monitor their systems. They want to be able to provision new instances. They want to have programmatic control. I mean, things like APIs to drive their systems are really popular among not just Web 2.0 startups and Facebook app developers, but really companies that are building applications for mainstream businesses, finance companies and insurance companies and manufacturing companies. They're all looking at new architectures to get the kind of Google-like cost for running applications, and that's driving them to want to have more control and get access to very easy, simple elasticity. But at the end of the day, the other really interesting thing about cloud is it has driven new business models, and a big part of that is about more transparency and simpler pricing for end users. I mean, people are very excited about things like pay as you consume, and very simple ability to monitor their own costs and pay for what they need and set budget limits and make sure they don't spend more than they can afford. And they're excited about the idea that that they're going to have some concept of portability, that they're going to be able to move their environment maybe from one provider to another and be able to really make sure they're getting a fair price for what they're consuming. So these are driving end users to the cloud, and I think the experience that companies like Amazon are seeing is really justification of this. I mean, there was a study done last year by one researcher where he figured out that in a single 24-hour period, Amazon generated more than 50,000 instances, just new virtual machines on their cloud, and they've driven. They're very secretive with their information, but they've already gone well over hundreds of millions of dollars in revenue that they're driving from the cloud. So this is a very successful model, and it's definitely becoming something that is naturally the extension of what service providers have been doing. And the good news is it fits perfectly with what most managed service or hosting companies' core competencies are. I mean, to be successful in the cloud, the same features and basically the same criteria are going to apply as were important for being successful in the very competitive hosting or managed service industry. So leveraging existing customer bases and having access to good infrastructure and good partnerships with infrastructure providers, and really the core skills. I mean, things like knowing how to do IT operations better than your competitor, knowing how to provide excellent customer support or provide the right customer support for the right customer, and how to provide how to do sales and marketing in this very competitive industry are going to be the key drivers from a service provider perspective for success. And I think if you look at it, there's a lot of people talk about, this cloud stuff is going to be very, very difficult for people to compete in. But I think at the same time, if you look at how competitive the world around shared and dedicated and VPS hosting and things have been, there's no reason to think that cloud is going to be any more competitive and more difficult to compete in. It's very much going to depend on which companies are successful moving their customer bases into the cloud and attracting new customers, going into new markets where people are interested in this stuff. Think about things like private clouds for universities and enterprises and developers building new applications, getting them started and allowing them to grow. I mean, some of the biggest customers on Amazon, have started with 5, 6 servers, and within a year they're running thousands of virtual machine images to run different types of Web 2.0 applications. So the cloud's flexibility and ability to expand and cover lots of people is really going to be a key for the success of service providers. And as you think about, okay, I mean, assuming you're here because this is a topic that interests you, some of the things we hear constantly from customers is, what we need to make sure is that when we decide we're moving into the cloud, we have a platform that fills our primary requirements. And those typically are around making sure that automation is really end-to-end for the stack. I mean, the cloud, from a service provider perspective, is about delivering better service levels with less manual intervention. Things like automated high availability and automated failover, understanding how to respond when a storage server goes down, or how to respond when a physical computing node blows a hard drive. All those things need to be in the software. They need to manage and they need to respond to those things automatically. But beyond that, the services that are important to end users are also important to service providers. The cloud needs to be able to support a broad range of operating systems and hypervisors and be able to support different types of network configurations. It needs to leverage all the stuff that, the expertise and the existing infrastructure that you've built in your business. I mean, if you're starting from greenfield and you're not leveraging your existing billing practices, your existing operations management practices, it's probably going to be it's going to be much, much more expensive. And I think that's really one of the things you think about as a service provider looking at this, is that, people like Google and Microsoft are they're willing to bet, hundreds of millions of dollars on their cloud plays. As a service provider, one of the most important things is finding someone who, A, understands the specific requirements of your business, so support for things like resellers. How can, as a service provider building a cloud, it's important to have delegated administration, things that are very unique to your industry. But also it's important to have a business model and a partnership that is really built on revenue sharing, so that you're able to get into this market without spending tens or hundreds of thousands of dollars, and grow your cloud over time. So these are some of the things we've heard. There's lots of other ones that are more technical and detailed, and maybe we can talk about those as we go. But really, what as you think about building a cloud or partnering with a company like VMOps or doing something to get into this industry, one of the things you'll pretty quickly realize is that to create an infrastructure cloud, it's very similar to actually creating a data center. I mean, you have to understand and manage every layer of the user experience, and that means having a concept for what type of hardware you're going to use in the cloud, how you're going to provide multi-tenancy or user isolation at the network layer, how you're going to do the same thing for the storage layer, how you're going to, what type of storage you want to use, whether that means local disks or, high-end EMC SANs or, NetApp or EqualLogic or things like OpenSolaris and ZFS. I mean, there's lots of different options, and picking the right level of storage and storage management is critical to delivering an effective cloud that meets the SLAs you want to deliver to your customers. And then obviously the hypervisor becomes a very critical element of this, and deciding which hypervisor to use and how to integrate that hypervisor to connect to all these pieces. And if you think about this stack of requirements, really this is what companies like Rackspace, who went out and bought a service provider in SliceHost and spent a lot of time working and built, had to do. They had to integrate all these pieces together, and then they had to integrate the service management layer, the user interfaces, the APIs, and then integrate it with all of their existing systems. And that's, obviously that for most companies, that's a multi-year, dozens of developers project. And this is the opportunity that companies like VMOps are looking to address, is, building infrastructure platforms that can sit on top of existing hardware or commodity hardware that you want to leverage and turn that into an infrastructure cloud automatically. So if you drill down a little bit more inside of what an infrastructure cloud looks like, you're basically, you're going to run the system on commodity hardware, standard x86 servers, standard gigabit switches, and whatever type of storage is appropriate for your customer base, whether that's a SAN or it's something like, local disk or DAS-based, network storage. And, on top of that then, because you're going to be using, lots of different types of systems probably, the important elements are how all this gets tied together. So one of the things we've developed is what we call the multi-tenant hypervisor. And the multi-tenant hypervisor is, at one element it's a hypervisor like Xen or KVM or VMware, but it sits around that. So we don't actually build a hypervisor. We sit on top of these hypervisors like Xen. And what we do is we sit at the device driver layer of this hypervisor and do all of the management of the virtualization of the networking and the storage and making sure this environment can scale. So a lot of the work happens with saying, okay, a user's created a new instance. Now I've got to set up a private network for them. Now I've got to connect their virtual machines to the storage, and I've got to monitor this entire environment consistently and allow them to scale it across, potentially even, multiple racks and multiple data centers. And all of this infrastructure work is really the hardest part of implementing and delivering a cloud service. I mean, it's stuff that we worked on, for more than a year to really get to a point where it's production grade. It's because it's very important and it has to perform given so much uncertainty, given the fact that servers fail and networks get disconnected and storage servers go down. And it has to still be able to respond to those things and provide as much as possible the user with a consistent and available experience. So on top of this infrastructure layer of work, the other big element that goes into any computing cloud is the management server. It's a piece of technology that sort of sits on top of all of these computing nodes running a hypervisor, manages them, delivers things like service offering management and the end user GUI and API and the integration points for your billing system and your user management system and portal, and all the administrative tools and monitoring tools for services like high availability, so that you can detect when a virtual machine fails and respond. So those are sort of the elements that go into deploying this. And how it's deployed is typically pretty straightforward. Users will roll it out as small as a single rack of servers with attached storage and networking switches, and then grow that inside of a data center to make up an availability zone. And even then roll this out across multiple data centers to create a cloud that spans multiple environments, and all of these being controlled by a single management server cluster that monitors availability, provisions systems, and gives the user the interface to run in the cloud. So as you kind of drill down into what a cloud would look like for your company, really important questions are, do we want this to run in a single data center? Do we want it to run in multiple data centers? What kind of services do we want to put on top of this for the customer around disaster recovery, around around storage and backup across different physical locations, and maybe look at opportunities to partner with other people that are building clouds in different parts of the world to combine to provide a high level of service offerings for your customers. So I hope this gives kind of a high level idea of what a typical computing cloud environment looks like and what's going on underneath it and what's getting deployed. I want to jump in now and switch over and give you a quick demonstration of the VMOps environment.
Hey Shannon, before you move on, can I jump in with a question from the audience?
Absolutely.
Okay, well, the question is, it basically just says, who are VMOps' primary competitors? I might expand on that a bit to ask, what other alternatives or what comparable alternatives might there be for someone who wants to build a cloud using third-party software?
Yeah, it's a great question. I think at this point, this market is still pretty new, so there's lots of different projects out there, lots of different companies out there that have built, different parts of this. Some of them have built, entire stacks. Some have built automation elements. Some have built APIs. Obviously, at the larger level, you have companies like VMware that have long been leaders in virtualization who are looking to, build applications, build some of this technology as well. So I think there's things out there. I think it's worth going out and doing a good investigation. I think, one of the things that we've seen a lot of is, there's definitely a trend of companies that maybe started off as grid computing companies or started off in the enterprise data center trying to reposition that type of technology as now a computing cloud. And I think it makes sense at one level. I mean, there's some similarities, but it doesn't tend to work really well because these things weren't really built from the ground up for service providers. They weren't built to, give the customer the ability to control everything. They weren't designed for multiple data centers and multiple, different types of APIs and different types of hypervisors. They were really designed for, big corporate environments where there was going to be a lot of control and a very educated end user. So, I think there's companies out there. It's worth looking around, but I think it's still pretty fragmented. And I think next year it'll be a lot easier to say, hey, there's 2 or 3 big companies that are leading this chase. But I don't know if that answers the question, but hopefully give you an idea of where the market is right now.
So you would say that the thing that would distinguish VMOps from potentially competing software might be the fact that you guys designed it with the idea of a hosting provider building a platform and offering hosting to customers of theirs right from the ground up?
Absolutely. I mean, I think that's absolutely a key distinguishing feature of ours. And I think, another distinguishing feature is just the amount of traction we've gotten in a relatively short time. And we started this company in 2008, and by the end of 2009, we had a number of customers that had deployed and were in production, running clouds with customers on it. So we've seen, that this market, while it's still early, this is very doable. It can be delivered. It can be done, with good partnership and good working together. And I think ReliaCloud can talk a little bit about their experience going through building their infrastructure and delivering a cloud to their customers that's very good and very reliable. So from a demo standpoint, what I'm going to show you here is just an example running in our lab of a fake hosting company, an environment they might set up, and just to give you a feel for what a user can do, because obviously that's going to be one of your, as you look at technology like this, one of the key questions is, what are the features for end users' perspective? So I'm just going to log in here with a new account. I probably have to find some username I haven't used before. And typically this type of a page isn't really going to be part of your core application. It's going to be a marketing page that you design to attract customers, or it might be part of an existing portal. And it's going to provision new users into our account. And this is where companies will set up their billing information, and they'll provide you with their credit card details. But I'm not going to do any of that today. And I'm just going to provision a new account for myself. And as you can see now, we're actually now into the application itself. And I'm going to just log in with the account I created. Hope I get the password right. And I did, and here we are now at the sort of the user console. And typically, across the board, our customers, being service providers, will take the infrastructure we've developed, will take the APIs that we expose to run the user interface on. It might take some elements of the user interface we've built, but this is all going to be rebranded by and large for their look and feel and the experience that they're trying to generate for their customers. But you can get a good idea of what the features of a cloud look like with this type of a platform. So I'm going to start just by creating a new small instance in the cloud. So an example of this would be, you can see here, I just clicked on the new instance button, and I can pick from whatever different offerings a service provider wants to make available. So, you can decide if you want to have, hourly billing and small instances, or monthly or annual billing. You can really offer any type of service plan that you want to a customer, as well as any type of software template you want to create. I'm just going to use a basic Linux template here. And for the purpose of this demo, we only have a single availability zone, but this might give the user the ability to say, okay, I want to run this in what data center 1 or maybe in data center 2 or somewhere else in the cloud. And when I hit create, it's basically going to provision this new user not just a virtual machine. The virtual machine is starting up right now, but it's actually going to go through the process of provisioning the user a virtual router as well as a virtual network and an IP address, and connect all those things together and go through the process of starting up this first virtual machine for the user. So the first virtual machine typically takes a minute or two longer than later virtual machines. So maybe this will take a minute and a half or 2 minutes to actually start the first virtual machine. But the reality is it's incredibly quick for users to get access to machines and then to begin interfacing with them. Because behind the scenes, we're doing all the work that's necessary to get this machine available on the internet and connected out to things like your public IP addresses. In fact, if you look here on the Events tab, you can see sort of what's been happening in the background. You see we created the account, logged in, and the system automatically acquired an IP address for me. It created the domain router I was telling you about and tied that up with the IP address I have. And then it started creating the virtual machine instance, and that's just booting up right now. And if we want, we can come in here and start another instance, maybe a Windows instance in this case, and get that started. And you can see now that our instance has been successfully deployed. The system's automatically given me a root password for the machine. So I'm just going to copy and save that up here. And if I click here, I can actually see the environment running. I can see this new virtual machine that I've provisioned. It's it's a CentOS machine as I requested. It's got a small, it's the small instance as requested. And I can do a number of things here from the console, all of which are also available to the end user through the API. But I can stop the machine. I can reboot it, destroy it. I can turn on high availability, which means that the management server now is going to monitor the availability of this machine. It's going to monitor the availability of the hypervisor running it and the infrastructure is running on. And if any of these things crash or fail or the heartbeat is lost, it'll automatically restart this machine. Because we're using network shared storage, it'll automatically restart this machine on a new piece of hardware and get it back available for the end user within 20 or 30 seconds. So the user can set that up for a single machine, or they can configure load balancing and run lots of front-end nodes and multi-tier applications in this environment. I can obviously reset my password. I can change the service level of what I've set up. And and I can even, you can see here I've got a little console. If I click on the console, I can even actually get access directly over my my browser to this machine. Log in with the new password I have, and I now have access to a machine. It's been maybe 2 or 3 minutes since we requested it. I can start installing software, start installing Apache, and get this machine configured and available for whatever purpose I want. Within a time that before I probably couldn't have made the phone call to start provisioning a dedicated server. So again, you can see why customers get excited about having access to this type of infrastructure and getting it going. Now, there's obviously other things are important in the cloud, things like elasticity, so the ability to create new service levels, and if I want to upgrade from a small instance to a larger instance, I can do that here. I need to restart my system, but I can very quickly, basically shut the system down, add more memory, disk, or CPU capacity, reboot it, and have more capacity on the same machine, or just start a new machine with more capacity and migrate my environment over to that. And the other thing that's very important in the cloud is because we're delivering infrastructure, it's important to give users the ability to really manage not just the machines, but also this virtual network and the virtual data center they're running in. So as you can see here, all of these machines are given a private IP address, but we've assigned the user a public IP address. They can request additional ones if they need them. You can see I just added another IP address to my environment. They can set up things like port forwarding, or you can configure this as security rules if you want to. I'm just going to forward port 80 to port 8080, and save a rule like that. Pick the machine I want that to go to. Pick the IP address that I'm setting it up for, and create those rules. Similarly, I can do the same thing on the load balancing side. If I want to, maybe load balance my SSL traffic, I can do that easily and set something like this up, and very quickly I can start to configure complex environments. And one of the really neat things about the cloud is that it gives service providers the ability to provide so much more than just an operating system and infrastructure. I mean, one of the things you'll see with companies like Jason's at ReliaCloud is they're providing a great catalog of different types of software for users to deploy. So Windows instances pre-configured with SQL or pre-configured with Plesk or set up to run with a .NET framework, and Linux instances with a LAMP stack built in, or we have customers that have Viata firewalls that are virtual templates that they're deploying into these environments to build more complex setups. So there's just so much that's possible with the cloud, and as it grows, I mean, there's things we're working on right now, like support for VPN. So you click here and you have VPN access now directly back to a corporate data center, or or the ability to manage your own private templates as opposed to just public templates. So this is really a great opportunity for stuff to continue growing and evolving as the cloud gains steam. So, Liam, I think that gives us people hopefully a good idea of what something like this might look like. What I'm going to do now is I'm going to transition this over to Jason, and he's going to walk through a demonstration and a little bit of discussion about what they're doing at ReliaCloud.
While you're passing it over, I'd just like to. We've actually got a ton of great questions submitted while you're running through the demo, and I just wanted to remind everyone that. We're going to spend a lot of time answering questions at the end, and in addition to that, if your question doesn't get answered during the course of the presentation, somebody's going to follow up with email, and we'll definitely get all the questions answered. So, yeah, please keep submitting questions, and so far, so good.
Okay, well, Jason, I think I've just passed you the ball, and you should be the presenter now.
I do see it. Thank you, Shannon. I'd like to thank VMOps, and I'd like to thank WebHost Industry View today for inviting ReliaCloud to participate in the webinar. Just give me here a moment, and I will set up the presentation. Can you see that okay, Shannon?
Yep, it looks great, Jason.
Great. So let me start off by just talking a little bit about ReliaCloud. ReliaCloud is a new cloud platform that's built by the same people that built VISI, a large regional managed service provider located in the Minneapolis-St. Paul region. Our ReliaCloud platform is really focused on three things. It's focused on reliability, it's focused on elasticity, and it's focused on providing cost-effective infrastructure to businesses and partners. We operate our cloud platform out of two different data center locations. Today it's primarily based out of a St. Paul data center location, and then this spring we will be adding a second availability zone in a second data center location. And our data centers are SAS 70 Type 2 certified, which we find is really important to customers who are operating within a highly regulated environment. We have 10+ years in the data center business and managed hosting business. And one of the key differentiators for our cloud platform is that we provide customers with 24/7 live support, and that's built right into our portal. And I think if we have a few minutes, I'll show you what our portal looks like. You can find out more information at our website, www.reliacloud.com. So why did we decide to build a cloud computing platform? I mean, why did we decide to even get into the cloud computing business? We've been watching the evolution of cloud computing and the hosting industry in general now for the past several years. And I think the way that I looked at it was that if you really strip away all the hype surrounding cloud computing, and I'll be the first to admit there is a lot of hype out there in the marketplace coming from, not only vendors, but coming from blogs and so on. But if you strip away all that hype, I believe that as a hosting provider, we would still build what we call a cloud platform, because at the end of the day, cloud computing is the most efficient way for us to deliver infrastructure to our customers. It's incredibly efficient. It leverages shared infrastructure, leverages virtualization, and maximizes the potential of the hardware infrastructure. It's also very standardized, so it's easy to add new customers. We don't have to start from the drawing board and build a one-off solution for every single customer from an infrastructure perspective. We have this large cloud computing infrastructure, and we can easily build out infrastructure for customers. So it's just a very, very efficient way to provide infrastructure to our business customers. And if we had never even heard of cloud computing before, we would still build this type of platform. Customers over the years have been asking us for this type of dynamic infrastructure. We've had customers who are seasonal in nature, and so during different points of time during the year, they need more infrastructure. We've got customers who've been asking us for infrastructure that will scale with the demands of their business, both up and down. We've had customers that have come to us and said that their web application is going to be featured in the national press in the next month, and they're wondering if their infrastructure is going to be able to scale to handle that load. Well, a cloud computing platform makes it really easy for us to meet many of those dynamic infrastructure needs. Cloud computing is also a cheap infrastructure that we believe matches today's recessionary climate. I've had customers in the last year that have come to me and said, Jason, you know, we bought all these dedicated servers a few years ago, and you know, now my business is down 40%. You know, and so they're in a difficult situation because of the recessionary climate. They're trying to understand how they can sort of right-size their infrastructure to meet the current demands of their business. With cloud computing, that's really easy to do. It's really easy to scale both up and scale back down. And our belief as a regional hosting provider is that we can service a unique niche, not only regionally but also nationally. I mean, the fact is that there are big cloud providers out there in the marketplace today. You've got the EC2s, the Microsoft Azures, you know, the Googles of the world, Rackspace, and so on. But there's no way that those providers can service 100% of the needs in the marketplace. And frankly, you know, it's cloud computing is we're still in the early adoption phase of cloud computing. So it's not like we're trying to take market share away from somebody like Amazon or somebody like Rackspace. The market share, you know, the market potential is absolutely huge, and we believe that there's a way for us to carve out our niche. And finally, not only can we leverage a cloud computing platform to provide cloud hosting services to our business customers, but we can actually leverage this platform to create new products. I think of it like, you know, what if I wanted to offer a hosted CRM product to businesses? Well, I could actually leverage our cloud computing platform to do that. You know, the customer would have no idea how I'm actually delivering that CRM application. You know, so in the back end, I'm just using my cloud computing platform because it's all completely automated. It's very fast. It's very efficient. So I get the benefits of not only selling this infrastructure to customers, but I can also consume it and leverage it to deliver new products. One of the early questions that we had when looking to build a cloud computing platform was, do we build it ourselves or do we go out into the marketplace and try to buy it? And this is going back about a year. It's when we started early 2009 is when we really decided in earnest that we were going to build or we were going to create a cloud computing platform. And, you know, my initial thinking was that we were going to actually go and build it because there really weren't any viable cloud-in-a-box type solutions out there, especially ones that were oriented towards service providers. My organization is Microsoft Gold certified. We're VMware certified. So we actually, I think initially we looked at building a cloud solution leveraging VMware. And we spent about 3 months doing sort of a bake-off where we reviewed a number of different technology options from VMware to Citrix and their C3 platform. We talked to the guys at Anomaly. We talked to folks at Eucalyptus. What we found was that many of the cloud computing software companies out there that were kind of building these solutions that leveraged commodity hardware, they were building cloud solutions that mimicked Amazon EC2. And frankly, that's not what I wanted. I didn't want to be another Amazon EC2. It just weren't enough differentiators there. I didn't believe that it was a good fit for our customer base, which is generally small, medium-sized businesses with some enterprises participating. I was looking for a solution that really was focused more on some of the high availability type capabilities you might find with a VMware infrastructure. So I talked to a number of CTOs out in the marketplace that had actually gone ahead and built their own cloud solutions, and I figured it, and my estimate was that it would take us about a year and around $1 million in-house to build and roll our own solution. And actually, the CapEx wasn't really a problem for us. The biggest challenge was really the timing. I didn't want to spend a year trying to build a solution to get it out in the marketplace. I figured we just didn't have that much time to build a solution. So I was introduced to the folks at VMOps, and I think I was immediately intrigued by their solution. The one advantage I saw that they had versus a number of the other cloud software platforms is that VMOps was really focused on the entire stack. They weren't just an orchestration software piece. They were also providing the actual network layer and the network routing. They were providing the computing nodes. They had built the actual storage. And they had integrated all of these components into one full stack that also had a complete API. Some of the other solutions they looked at, they would provide one piece of the stack. So they might provide the software. They might provide the virtualization orchestration piece. They might provide the computing nodes. But very few of them would actually provide you with something like the storage, and very few of them would provide you with the network and routing layers. You really had to figure out those pieces on your own, and as you dive into it, you'll find out that those are really tough pieces to figure out. I mean, it's easy to go out and buy a stand and hook it up to a bunch of computing nodes that are running hypervisors on it. But to do that in a way that is scalable is actually quite challenging. And we wanted to have a cloud computing infrastructure that would scale from one customer to 100,000 customers, and something that we could build in this very standardized fashion. And that's really what VMOps provided for us with their cloud stack. And then finally, VMOps we felt was really the right size partner for our organization. We're not the largest hosting organization in the country. We're a large hosting organization in our region of the country. And we talked with the folks at VMware. We talked to folks at Citrix and Microsoft and so on. The fact of the matter is that those kinds of organizations, they were much more interested in working with the very largest service providers. I mean, I remember talking to VMware about their vCloud initiative, and frankly, they were just interested in the top handful some of the largest service providers in the country. Those are the ones that they're really targeting with that solution. So when I talked to VMOps, I felt like we were really a perfect size and a perfect fit for their organization, and I can say it's been a great partnership that we've had with them. So some more details about our cloud offering and how we're sort of positioning it in the marketplace. ReliaCloud is really focused on high availability. So all of our computing instances are persistent and highly available. If the underlying physical node in which your computing instance is running, if that node were to fail, then your virtual machine will essentially restart somewhere else in the cloud. That's a message that's really resonating with our customers, especially those customers who are familiar with something like VMware's HA capability. We also created a true hardware firewall security perimeter around our cloud platform, and we leverage Cisco ASA firewall boxes for that hardware firewall security perimeter. And again, that's really resonating with businesses as well because that's what they're accustomed to. One of their fears when moving their applications and data out to cloud providers is the security. And sure, you can take your data and applications and move it out in the cloud, and you can oftentimes you can sort of roll your own firewall system. You can use a software-based firewall system. But what we found is that customers really like the fact that we're using hardware firewall security systems. We provide a full web portal and a full API, and I'll show you the web portal here in a bit. We actually leveraged VMOps API, so you'll see that our web portal looks completely different than the VMOps portal that Shannon demonstrated. We offer different server models, so we essentially provide anything from very small server models that contain a small amount of CPU, memory, and storage, up to very, very large server models that have 8 CPU cores, up to 16 gigabytes of memory, hundreds and hundreds of gigabytes of storage. So the customer can choose what size of server model that they want, and then they can pick the software template that they want to run on their server. And we offer both free and commercial software templates. The free software templates are running the various distributions of Linux, and we also support FreeBSD, and we're also working on Open Solaris. In terms of Windows 2003, Windows 2008, we're also doing Microsoft SQL Server in our cloud as well. So if you pick one of the commercial software templates, then you're going to pay an additional hourly rate. Everything is built by the hour, so starting at 5 cents an hour. In terms of bandwidth is 12 cents per gigabyte. That's outgoing bandwidth. We provide unlimited free inbound bandwidth. So all the bandwidth and all the network traffic between your individual cloud servers, that's all free. All that inner traffic bandwidth is free. We're only metering the outgoing traffic from your virtual cloud network. And then finally, customers can come to the ReliaCloud website. They can register with a credit card, and they can build their first server in about 60 seconds. We've done all the work to completely automate it from end to end. So, all the registration process, connecting the customer with the portal. The customer can manage their services in the portal, and then we've integrated it with our billing systems as well. So this solution is completely integrated from end to end in our platform. One of the unique things about ReliaCloud is that we're actually building a significant partner channel. So what we've done is, we've done all the heavy lifting work. We've built out the infrastructure. We own the data centers. We deployed all the physical servers. We've done all the development work and built a portal that customers can integrate with. And now we're actually extending that to partners. And we support 3 different types of partners, anything from affiliate partners who are simply sending referrals to us, to value-added resellers. These are generally IT consulting firms that are doing on-premise work at businesses. A lot of times they're managed service providers for small, medium-sized businesses. They want to leverage our cloud infrastructure and essentially resell that infrastructure to the customers. And then private label customers. So these are hosting companies that generally don't actually own their own infrastructure, or don't have the resources and time to build out a full-fledged cloud solution. So even though a platform like VMOps is great as a starting point for building out your cloud hosting solution, there's still generally some work involved. If you want to integrate it with your billing, you want to create the registration process, you might want to change how the portal works. So in our private label program, essentially, we're doing all that work for hosters out there that want to be able to offer these services, but offer it under their own brand, and they want to manage the customer relationship, and they want all the tools around that, so they can register customers, click billing, and so on. So let me jump into a quick demo of our portal.
Hey, Jason, this is Liam.
Yeah.
While you're doing that, just to give you a heads up, we're about 7 minutes away from the end of the presentation, and we can go a few minutes long, but just so you know, we're getting close to the end.
Yeah, and this is I'm going to just spend 2 minutes. Can you guys see my browser window?
Absolutely.
Yep.
Okay, great. So this is the ReliaCloud website. We built the front end marketing site. We built a ton of information into this site. You can go there. We have a knowledge base. We have online video tutorials of how the system works. We have a partner section for folks who are interested in becoming partners. And of course, we have a lot of information about how the architecture is set up, what the API looks like, and so on. You can easily register for an account. Actually, we're running a public beta right now. We'll be in general availability of this platform in a few weeks. Once you register for an account, you can log into the portal, and I've already logged in here. So you can see that our portal looks very different than the portal that Shannon was showing. We decided that we wanted to build our own portal because we wanted to wrap all kinds of functionality around VMOps, because we're not just providing customers with cloud servers using the VMOps platform. We're actually going to be providing customers with cloud storage using a platform developed by a company called Periscale. So we're integrating that into our portal. We also wanted to build in all kinds of account management features into the portal. We wanted to build in support functionality in the portal. So we found that leveraging the API was the best way for us to go in deploying our cloud platform using VMOps. And pretty much everything that you see in this portal is leveraging the VMOps API. So like you can see that I'm running a bunch of cloud server instances. I can right-click on those, and I get a contextual menu where I can perform actions. There's a similar menu at the bottom of the page. And then there's this kind of a fly-in and fly-out menu on the right-hand side that also changes depending upon what actions are selected by the user. Our portal was completely built by our in-house development team, and we used the portal itself is written in PHP, and we're using JavaScript pretty heavily in this portal as well, as you can probably tell, JavaScript Ajax. So we've gotten really good feedback from customers. We've been beta testing this now for 2 months, and we've been incorporating much of the feedback from our beta testers in improving the usability of our portal. So I think this may give you a good example of what is possible with the VMOps API and how you might be able to wrap or create your own completely customized and unique portal using their API. So that's all I have for today, and I'll be happy to answer any questions. Liam, I'm gonna pass over the presenter baton back to you.
Okay. I'd like to mention right now that we've got about 20 questions from the users. I doubt that we'll get through all of them, but let's try to do as many as we can. We'll go about 5 minutes long, let's say, and you know, see how that goes. I'm going to just skip ahead to the next slide here because it's got the contact information for both Shannon and Jason. You can certainly follow up with them offline if you like. I'm going to start going through the questions now, just throwing them at you guys. And if anyone else has any more questions, follow-up questions, please submit them. And again, we're not going to get to all of them, but we will follow up with emails. And you know, we do appreciate all the questions people are submitting. So let's start with the size of a pod. You know, is there a lower limit to how small a pod can be? Is there an upper limit to how big a pod can be?
Yeah, it's a good question. I mean, the pod is a kind of a physical context. It allows us to kind of know where virtual machines are and the servers they're running on and sort of the switch that they're connected to, so that when we provision a user's machines that they can be near one another. But it doesn't really have any hard limits. So you can have a pod as small as, you know, a couple storage servers and a couple, you know, computing nodes and a switch, and you can really have it as that small, all the way up to, you know, rack of servers or a couple racks of servers that are connected together. I mean, you don't really want to make a pod too big because the concept of it is that all the machines in a pod should have very, very fast connections between them so that they can communicate one another really well, and that you're not sending a lot of data over your data center backbone between, say, pod A and pod B. That's not to say a user's account can't span, you know, 10 pods. It certainly can, but the logic in the provisioning is going to try and group those machines near one another to minimize the amount of impact on your backbone. So the pod's really not a limiting factor either in small or big.
Okay, I have another question, I think related to that question, and I might have to interpret this one a bit, but I think the question is, the question as written is, can this software handle dedicated hosting? I think they mean that as a management tool for managing the infrastructure overall.
Yeah, I think that's a really interesting question because I think this is actually heading in a lot of ways. These dedicated and cloud hosting are going to merge into one thing pretty quickly. One of the features actually in our product is a concept called domains, which is what we use to to kind of aggregate a whole bunch of accounts into a group. So, for example, if you had a university that was your customer, you might give them a domain, and they would then set up subdomains for their departments or give their give all their accounts. Students for that university would belong to the same domain. In our current product, everything is really virtual. A user gets allocated a shared resource, and their virtual machine is there, and they don't, they can't say I want to be on this machine all by myself. But in our next release, which is coming out at the end of the first quarter of this year, you're actually going to be able to do that. You'll be able to dedicate physical machines to a domain and say, okay, these machines are going to be specific to this user, and they're going to consume these, and no one else is going to be on this infrastructure. And when they need more capacity, they'll be able to burst out to the shared resources if necessary, or you can allocate additional dedicated resources to the user. And that same concept is going to apply to the networking layer as well, where you'll be able to attach dedicated VLANs to specific users and have those VLANs connect both dedicated physical servers that maybe aren't even part of the cloud to cloud instances. So there's quite a bit of that that's really exactly where some of this cloud stuff is heading.
Okay. We had a couple of questions related to the options available as far as small, medium, and large instances, for example. First of all, I think that the person wanted to know, what are the options available, and I think that you would explain probably that they're totally up to the service provider.
Yeah, that's exactly right. I mean, there's every service provider has to decide the type of service offerings they want to make. So it's some combination of of RAM, CPU, and disk that makes up a service offering. But on top of that, they also, another big area that users are going to have control of is the, what they make available in terms of software templates. So Jason was talking about, they have instances starting as small as, I think half a gig of RAM and going all the way up to 16 gigs of RAM. And you can have, there's no limit. You can only have 3. You can have 15 different service offerings, and you can also have any different type of billing models you want. I mean, a lot of people in the cloud are using pay as you consume or hourly billing, but we have other customers who completely think that's the wrong way to go, and they're building everything with the traditional monthly model, and that's fine. Our platform will work fine with whatever billing model or business model you want to use. And I think most people know their customers well enough to know which one is right for their customer base and the market they're going after.
Sort of along the same lines as what you were just mentioning now, somebody asked whether the billing interface is part of the product or whether you can use a third-party application. I know that Jason mentioned that they were using Parascale for storage. I don't know if the billing is similarly customizable.
Yeah, absolutely. The billing is, in fact, we intentionally didn't go out and build an entire billing platform on top of this because, again, we were targeting service providers, and the vast majority of service providers already have a billing system that they use. So we built an integration API that connects to that billing system and generates, very detailed usage records about customers. And, and there's some configuration there. You can parse that to a degree, but primarily that, you're going to use your existing billing system to, run your credit cards, charge your user, send your invoice. And we're going to tell you how much that user consumed from bandwidth, capacity, software, everything related to their cloud account as you need it. Whenever you need that information, that's all exposed via what we call an integration API. We also have, I didn't show at all the administrative console to the product, which kind of shows you how you configure and control and manage all that. It's a little different because it's obviously designed not as a end-user GUI type thing. It looks more like an enterprise management console. Lots of different tabs and lots of different types of actions you can take to configure, everything as well as provide support for your end users.
Okay. Now, this is an interesting question. Now, what if is there an opportunity for you to use APIs and something like EC2 or Azure to expand to account for the possibility that you would run out of infrastructure yourself?
That's a really interesting idea. Azure, I think it gets into a little bit of complexity because it doesn't really leverage infrastructure, and it's not something that we have anybody doing today, where they have their core cloud, and then if they ran out of physical infrastructure, they might go out. What we've seen more of is that among our cloud providers, there's been a lot of conversations about partnering and about how different regional partners in different parts of the globe might work together to provide a larger cloud. So I think there's a lot of interesting possibilities there. Some of those things are realized. Some of those are still, I think, going to depend on the ingenuity of the hosting provider, service provider that kind of puts together those different business models. But we'd certainly be open to talking about those type of things and figuring out ways to solve those very interesting technical challenges.
Okay. Sorry, I guess the high availability systems, are they replicated in different physical locations, or is this an option that you can choose?
Yeah, there's lots of ways to configure high availability, and right now high availability in the cloud is really still at the virtual level. It's basically saying, we're going to allow you to create a VM, and we're going to allow you to to be sure that that VM is running, and if for any reason something happens in the hardware layer that causes that VM to go down, we're going to respond to it and bring it back up. So we're going to manage the hardware, we're going to manage the storage and the networking, and make sure these things are available to make the service available. One of the areas that obviously this gets really interesting when you start to talk about multiple availability zones is setting up geographic redundancy and geographic failover and geographic load balancing, things like that. And some of those things, we have service providers doing those things, and they're really implementing that as value-added service on top of the core infrastructure. But this is an area that you're definitely going to see more functionality coming over the course of the year as we, as the platform goes from version 1 to 2 to 3. We'll be adding a lot of integrated, automated things like geographic load balancing and geographic HA and DR. But right now, it's really mostly about inside of a user's environment, making sure that infrastructure, they can sort of abstract away infrastructure failures. So if there's a failure of one piece of the infrastructure, the cloud responds to it and gets them back online. and things more complex than that, things like multi-zonal DR, are still being mostly handled by the the expertise of our customers, the managed service providers.
Okay. Somebody wanted to know what virtualization software the panel runs on, whether they need to be running something on the back end. My understanding is that Zen is built into the VMOps platform.
Yeah, that's a great question because our first version of the technology, Zen, is built in, and we leverage open source Zen, same as Amazon and Rackspace. In the next release that's coming out, we're extending that hypervisor support so that we'll support not just Zen but also KVM and VMware, and that's going to be a really important change because it'll allow you to set up inside the same cloud multiple hypervisors and then pass that decision on to your customer. So we're adding the first batch is Zen, KVM, and VMware, and then follow on reasonably shortly thereafter will be Hyper-V. And what it'll allow you to do is say, Mr. Customer, if you don't care, we'll run our system on this. But if you happen to be a big VMware shop and you've got a number of VMware instances that you want to move to the cloud, we're gonna allow you to do that. We're gonna run a VMware cluster and manage that from the same interface and control that through the cloud. So the extendability of this stuff is really where the future in cloud lies. It's about mapping to the customer requirements, and doing that means supporting different types of infrastructure and different types of hypervisors, even from the same cloud and from the same control panel. So it's a great question, and it's a question that the answer is still evolving, I think.
Okay.
If I could add to that, one thing that we found was that there are certain software stacks that are only supported in a virtualized mode on VMware. So if you want to run those software stacks in the cloud and get support from that vendor, then you better be running on a VMware platform. So that was one of the challenges that we found, and one of the reasons that we're excited about the fact that VMOps will support other hypervisor platforms, most notably VMware in the future.
Okay, we're running pretty long here now, so I'm going to just ask you one or two more questions, and then we'll wrap it up. There's a lot of questions that didn't get answered, and I just want to reassure everyone that those will get answered via email, so thank you very much for submitting them. Sorry, somebody wanted to know if there's an opportunity out there for them to look at the admin console as a demo somewhere.
I'd be happy to give somebody a demo of that or point them to something. So if you email me at shannon@vmops.com, we can set up a WebEx, or I can point you to some stuff, and you can take a look and see what the administrative side looks like. I'd be happy to do that.
Okay. I guess the one other thing that I thought was kind of interesting was they were asking, well, there's two that are very similar, actually. One is how scheduling works for the VMOps, and I'm assuming they said, can you assign priorities, or is it first come, first serve? I'm guessing they mean in terms of spinning up instances.
Yeah, that's a good question. I mean, one of the things that you can do today is, generally everything is done on a first come, first serve basis in terms of API requests, but we're actually adding some ability to reserve functionality into the API right now. So that's something that we're going to be able to support very quickly, is the ability to schedule different actions and have those kick off at different times. But the API is primarily on a first come, first serve basis today.
Okay. Somebody wanted to know how you handle memory on the nodes on a physical server, for instance. How many you can create, or how do you know how many you can create on one server? And if somebody wants to upgrade from 1 gig of memory to 8 gigs of memory at one time, would you then move it to another machine, or how does that work?
Yeah, that's a great question, and it shows pretty good knowledge of how this stuff works, because memory ends up being by far the most valuable resource in the cloud. I mean, because you can over-provision a lot of things, but memory is the one area you don't want to get into a ton of over-provisioning on it. It just has implications in performance and failure. So, what you'll find pretty quickly if you look around is that most pricing in cloud services is driven by the amount of memory you want dedicated to your environment. And so what we do is we basically, we firmly commit the memory to each user. So if you've requested a gig of memory or 2 gigs of memory, that's how much you have. And so when a new server is added to the cloud, we assess its capabilities and we see how much RAM it has, and then we reserve some of that, a little of that for the hypervisor, and then we basically slice that up. And when the RAM runs out, then we stop provisioning machines to those systems. because it's one area we don't want to be maxing out on. So if a user is running on, server number 247 and that system's out of RAM, and they've said, hey, I want to actually, jump from, I want to, bring my image up with more than 2 gigs, I want 8 gigs. We'll actually, we'll move them to a new server and put that when they restart the machine. We'll provision that to a new place that has the capacity to handle the amount of RAM they need. So that's all part of the logic in the system. It monitors those things and handles that as users request different amounts of capacity. It finds that availability.
Okay. Well, again, I don't want to go too much longer, so I think we'll call that a day for questions. And again, thank you to everyone who stuck around long to listen to the answers. Thanks to everyone who submitted questions. Thanks to everyone who showed up and has already left. Thank you very much to Shannon and Jason for delivering a really great presentation today. And I wanted to remind everyone that, first of all, that you can contact Shannon or Jason directly via the info on the screen here, and that if you want to watch an archived copy of this webinar or other WHIR webinars, you can go to thewhir.com/webinars, and this one should be up in archive probably by the end of next week, and there's a few others up there now. Thanks again to everyone. It's been really great, and have a great day. Thanks, guys.
Thanks a lot, everyone.